Hello, everyone. My name is Taylor McCampbell, and I'm joined by Rayford Cooley. We're members of the Cedar Lab, and my cohorts on the Industrial Control System Outreach Training Development Project. We're Michael Pate and Taylor LaForce, and we'd like to present our project to you today. So, the background for this project is basically insecure critical infrastructure. So, critical infrastructure is very antiquated in terms of the technology it uses, and that makes it insecure. And when we rely on critical infrastructure for things like nuclear energy and power plants, water supply, that makes it a massive security vulnerability. So, like I said, the security of these systems is antiquated, and there's been an increasing amount of attacks on critical infrastructure, specifically ransomware attacks like DarkSide. We have things like TrickBoot and just other attacks that are targeting critical infrastructure. Threat actors are trying to get money from people, and the best way to do that is to attack something that absolutely needs to be working at all times, which happens to be our critical infrastructure. A consequence of this is that there is physical world damage if infrastructure is successfully attacked. So if water treatment facilities are successfully attacked, then we have chemicals in our water that we don't want there. If nuclear facilities are successfully attacked, then we have nuclear vulnerabilities and things happening with nuclear energy and nuclear weapons that we don't want to happen. It could be quite catastrophic. Also, a problem that presents itself when we talk about critical infrastructure is that we have a lack of spare equipment and a long lead time. A lot of these, or a lot of backbone parts that our critical infrastructure relies on is not manufactured in the US. So if something breaks, it takes a long time to fix it. So we need to generate solutions for these problems.
At the beginning of the summer, we started this research project by focusing on a few problem statements that we wanted to try and solve. One was the training and education that we normally would receive in, for example, a university. In a university setting, mainly focuses on the cybersecurity skills and the information technology side of things, instead of on the operational side of things. And so with these modules, we wanted to focus on developing training and developing education for the workforce education that focuses on the critical infrastructure side of things and the security, and specifically the security for this critical infrastructure. And through these training modules that we wanted to develop, we wanted to bring about an awareness of where industrial control systems are present in your everyday, and kind of informing the public of how these systems work, how they may be compromised, and sort of how training can be used in order to properly secure these systems.
So the methods we used to accomplish these goals were basically building models of critical infrastructure that you find in the real world, building out those operating environments, so including networking equipment, databases, developing custom software for the controllers, connecting them all together, attacking those models, and then documenting how the attacks worked and what we did to mitigate those attacks. So the traditional workflow is just that we would develop a model in basic that we could 3D print. We'd 3D print the model. We'd write software to connect the model together and have it communicate and be controlled by different PLCs. In doing that, we'd build out the operating environment. So we'd include databases for storing data, controller software for the controllers, like I said, and networking equipment to connect it all together and to kind of model these networking communication softwares that these real world models use. And then we'd attack the model using side channel attacks or voltage glitching. And then we would document how we did the attack and document mitigations or ways to defend against this specific attack.
So at the end of the summer, we had successfully developed all of the 3D models necessary for our different modules in order to be printed. We also have the controller software, so the software that runs these different controllers, like the Controlling Omega, as pictured there, or a microbit. We have some of the network equipment for the range configured and in place so that we can support the networking side of these modules. We also have a custom HMI developed, a custom website that we made in order to control this equipment. In the works, we also have a paper that's being written to describe the different voltage attacks that were performed upon our windmill farm model. And we have also made a activity for the Gen Cyber Summer Camp, which is a K-12 targeted cybersecurity summer camp where students and teachers from the K-12 range can come and learn about cybersecurity skills. And our module that we developed was based on solar panels, and we are using two different microbits in order to control those solar panels. So this activity is focused on teaching this early range of students, this K-12 range of students, security as it pertains to the operational side of a solar panel.
So in the future, we want to obviously print the 3D models and build the models. So we want to connect our controllers together and wire our models so that they model these real world systems. We want to be able to document what we did. One of the main problems that we encountered when we were doing this project, especially in the early stages, was finding documentation about how these technologies like HMIs and PLCs actually worked. So we want to be able to mitigate that problem and develop some documentation, good documentation for what we've produced. There's also a lack of free, documented, and reputable human machine interfaces, or HMIs, which is why we had to develop our own custom HMI. That was definitely a challenge in this project, and we'd like to also mitigate that problem by eventually making our HMI open source and well documented and easily used by beginners to the industrial control systems landscape. We'd also like to experiment with man-in-the-middle attacks, which I mentioned before, which is just another common way of compromising industrial control systems. So that was the Industrial Control System Outreach Training Development Project. Now we will open the floor to questions.